Okay, thank you guys. Welcome again to um, our channel. It's been a really, really long time, and I apologize for the long break. Uh, yeah, so alhamdulillah, we are back. Okay, so today we are continuing on something that a project on the side that we had started but did not really pursue through with it. So today we are again starting it up. Hopefully this time we don't take too much of a break that we have taken before. And then I also hope that this time the sound is good because many persons did complain about the sound. um, I don't have such a great microphone, but I do have one which somehow works. So please bear with me. I know the sound might not be as great, but please bear with me. Okay, so the goal behind this series is for me to make sense of each and every page of a given schematic. This helps an engineer, or this helps an Apple technician to be able to have a better understanding of a given circuit, of a given logic board that they are working on. It's very crucial for you as a technician to understand how a schematic is, how the meaning of your circuit diagram. It's important for you to be able to read your schematic and also be able to make sense of your schematic and be able to apply that knowledge into real repair. So if you are able to read, understand, and apply that knowledge into real repair, it makes your repair very, very easy. And then what it also does for you, it's that it gives you a grounded basis upon which you can develop and you can build upon. So today we are going to be using a very common um, device, which is a very common Mac line, which is your MacBook Air A1466. This is the model number is A1466, and the board number it's 820-00165. I'm just going to show you guys that. So it's 820 dash, so that's it. So it's 820-00165. Although here it's not, there is no there's supposed to be like a dash there. So but then you only have 820, and then you have like a, but it's supposed to be, I mean, it is, you quote it as 820-00165. Now, one thing about the 820, that is a universal base quote for your logic boards. When you're asked about what's your board number, it all starts with 820 and then followed by the either four digits. For example, like the MacBook Pro A1278, that's the model number. That's your MacBook Pro 13 inches 2012. The board number of that is 820-3115. So you basically, in that case, you have four numbers after the 820, but the MacBook Air 1466, you have 820-00165. So and then there you have five numbers, five digits. So that there's really no that's whether it's four or five, it's there's really no much of importance to it. But the most important thing is for you to be able to quote a number, to quote it for the relevant persons to make sense of what you are trying to refer to. Okay, so the MacBook Air, like I said, is a 13 inches. It's and this is the 2015-2017. So you can use this schematic for 2015, 2017. You can also use the schematic for a 2000, because some of the pages here, there are similarities. There are certain pages here that you can that have a similar this similar pages with your 2011, 2012, 2013, 2014. So somehow you still can use certain pages of your 2015, 2017 schematic or circuit diagram for older design. But this particular one that we're going to be dealing with, it's a 2015, 2017 schematic. So let's begin. So what we're going to be doing, like I said, we are going to be making sense of each and every page. So this is me as a technician. I open up a schematic and I want to make sense of it. Now, I do want you guys to understand that in actual repairs, this is not how you go about it. In actual repair, you go to the page that is relevant to the issue that you have. Say, for example, if I am working on a machine that it's a no backlight and I have backlight issue, what I'm going to do is I'm going to navigate to the page on my schematic that speaks about or that details um, um, the design or that details my backlight circuitry. So in what we are doing, so we are not going to be tackling issue specific. Rather, we are going to be going through that. We are going to be going page by page of your schematic and then trying to make sense of what's on your page and how to identify or make sense, basically, to be able to. So that way, hopefully, when you have issues and you need to deal with a particular issue, first of all, you will be able to navigate your way through the schematic, and you can be able to also make sense of what of the schematic. Okay, so say for example, if I know, so at the top here you have where it says you have your file. I mean, that's where you obviously, if you want to open a new if you want to open a new schematic, you can do that from here. You can also go to your you can also obviously go to your finder. Here you go to your finder and then to access either from your downloads or your documents or your desktop, whatever. You can also access your board's views as your schematic, sorry, your schematics from there. Now we already have one that is open. Like I said, is the 830-00165. Now here you have your file you can open, and then obviously you can go to your recent. Now don't worry about, we are not concerned about that. Now you have edit, we're also not concerned about that. Now you also have view. Now view, this is basically how you want your schematic to display. And then we have the go-to. Now the go-to is the one that I think most persons will want to obviously want to use. So say for example, you have the number of so I'm just doing this. So here you have the number of pages. You have the number of pages, and so you have how many? You have 76 pages here. So you have 76 pages. Now in each of the page, so say for example that I want to go to where the page that says my power feds. So that is on page 58. So what I'm going to do is I'm going to go here and say go to, and I'm going to say go to page 58. I'm going to type in page 58, and then I can enter into it, and then it will take me down to page 58. Now so let's go back to our page. We'll go back to our page 1, and then I just enter it, and then it takes us back to the page that we started up from. So here, so there, most commonly you will be using the option of go to, and then also you have the next page. So you have the next, you have the, so now in terms of the next, and then you have another option that says you're up and or down. So you can just swap, you can just obviously do you can just do this with your two fingers. It moves obviously because I'm using a Mac. So on my trackpad, I can just do that, and then I'm able to move across the page. Okay, so when you say go to, you have the option of down, and then here the option of up is not highlighted. Why? Because there's nothing after this. So if we are to move down, for if we want to move one page, then the option of up and down will be present. Now you have the previous, and then you have as well as the next. Now you have the go-to page, which you just spoke about, and then you have the back. Now the next one is the tools. So here, tools, we are you probably will not really be making use of the tools that much, but again, depending on what you will be doing. But oftentimes when you're doing a repair, you won't really be interested in your tools. So I guess most of what your settings is going to be very much around your file, and then the option of your then the go option, so where you can either go to or your nest. Okay, so that's that. So let's just take ourselves back to the first page. So this is the first page. So here it gives you the number of pages you have on the schematic. And then here you can get an overview of everything that you have. On the first page, you can this is where you get an overview of everything. So basically here it just tells you, it says contents, and then you have your table of contents, your bill, your bill of materials configuration, your bill of materials variants, your power delivery part, which is the PD, your CPU GFX, and then the NCTF, and then a slash reserved. You have your CPU miscellaneous slash your JTAG, and then your CFG, that's your configurations, and then your reserved. And then you have your CPU DDR3 referring to RAM. You have your CPU and your PC8. And in this particular machine that we are the 820.00165, your CPU and your PCH is on one die, and then you have your CPU and your PCH is on one die. So here it says, so on your page 8 is going to say your CPU slash your power, your PCH power, and then you have that on your CPU and your PCH in grounds, and then you have your CPU decoupling, and then you have your PCH, and then your PCH audio, JTAG, and then SATA, and then clock, and then you have your PCH slash PM on the slash PCI slash GFX. You have your PCH, PCIe, USB, LPC, SPI, SM bus. You have your PCH, PIO, miscellaneous LPIO. You have your, so basically this is basically the first page that gives you an idea of everything that is contained in the particular schematic that you are that you are going to be that you're going to be busy with. Now, in real-time repair, you would want to go to issue specific to say, for example, if I don't have sound, I want to go to pages that are related to sound on my schematic. Okay, so that's basically about that. The first page here, it's a summary of the pages that you have, like just as it said. So the summary of the pages that you have, and in this particular one, you have 76 in total. Okay, so let's now let's move to the next page. So here there's really nothing much here other than to get an overview. Say for example, if I want to go to the most common places that you want to go to will be your power aliases, your signal aliases. It's also, but most commonly it's going to be your power aliases, and that will give you the list of all the power rails on your machine, and that will be on, for example, that will be on page 62. So if I'm to say go to page 62, for example, I say go to page 62, that will give me all the list of power rails on the device. So this is going to give me the list of the power rails on the device. Now, 9 out of 10 in actual repair scenario, this is where you want to start your what? This is where you want to start your journey. But nonetheless, you're not only going to be interacting with this page, you're going to be interacting with each and every page of your schematic. So let's just quickly go back to page 1. So let's go back. So we're going to back to page 1. This is our page 1. So the next thing we're going to do is we're going to go to our bill of materials. So the first one, is your table of contents. That is basically where we are. The next one is your bill of materials configuration, and we are not really going to worry about that, because that is not we're not really going to worry about that, because that is not going to be relevant to you. 9 out of 10 persons that are looking to do a repair, or they are not really going to worry about the bill of material configuration. And then obviously the bill of material variants, they're also not really going to worry about that. And then you have the power delivery parts. Now the power delivery parts here, you're talking about uh, your CD3215, for example. I mean, that is so talking about your power delivery modules, for example, where your CD32, the USB port controllers are concerned. That's your power input and output controllers. So we're talking about, for example, your CD3215, your CD3217, your CD3218, as well as more advanced CD32 CDs that are used on, say, your M3s, and then as well as your M4s. Okay, so that's on your PD part. and then you have your CPU and GFX, and then slash your NCTF, and then you have also your reserved. And again, oftentimes persons that are doing repairs, they really will not have anything to do with the page 5. So let's just go to, let's just go to page so let's go to page, so we can just do this. Let's do this. So this is your page 2 now. Now page 2, so this is the bill of materials here that I'm talking about. Oftentimes you are not really going to worry about what you have here. It's not it's not it's not really relevant to most technicians. So we are not really gonna, so this information here, it's something that we're going to come back to at the end of at the end of more I would say more relevant pages, because for 9 out of 10 persons that are doing repair, they are not really going to be obviously interested in this. But then again, if you are doing say some kind of modification, obviously this might be important to you. But then uh, like I said, it's not an everyday type of repair. So 9 out of 10, you really not have a reason to be here. So that's on your page 2. So if I just zoom that out and just show you guys what that is, you have your bill of materials on your groups, and then you have your current sensors configuration, you have your CPU, DRAM, SPD straps, you have your programmable parts, and then you have your module parts, and then you have your DRAM parts, and then what else is here? You have a CPU DRAM configuration chart, and then you have your alternate parts. So so like I said, this is not really and then the description here says summary description says bill of material variants. Okay, so this, like I said, this is not really going to be something that a person who is looking to repair a board will be so much interested in, unless they're looking to do some kind of modification. Okay, so let's move on to the next page, and that's going to be page 4. So if we go to page 4, and then page 4 here, you're talking about the power delivery module parts. So here it talks about the part number, the quantity, the description, the preference, the preference description, the present description, and critical and bill of material option as well. Now again here, this is again here, a person looking to do a repair, it's not really going to have any need for this page. A person looking to do a repair is also not going to have a need for this page. So we are going to move on. So this is for example, this is a hole, and that is a sign for ground. Yeah, so that's a hole, and oftentimes now that is when you with that hole there, that's that's basically your screw hole on the main board, and that is directly connected to ground. Okay, so you have your EMI IO pogo pins, and again, like I said, a person who is doing a repair, it's not really going to be interested in that. And then a summary of this page says is what? It's power delivery parts. Okay, so so usually when you hear that, when you see the PD, it's talking about the power negotiations from a typical USB port, whether it's the management or the power management of either in and then out over a standard USB. Okay, so let's move on. Let's go to the next page, and let's go to page 5. Let's go to page 5. Let's see, what do we have on page 5? Okay, so page 5 here talks about our this is this is your CPU GFX NCTF reserve. Now here, for example, so here we are going to at least talk about what so let's talk about what you have here, and then how to make sense of it. So U0500, that is that it's basically the identification. So here you have your U0500, that's your identification. That's your Broadwell ULT, which is Ultra 2C plus GT2. It's a BGA chip. Now this is the CPU, and on this particular machine, on the 820.00165, the CPU and the PCH is on the single chip, is on the same die. So here, here it says it's critical. It's now let's just this. I think this is self-explanatory. Yeah. On the left hand side here, those are signals that are being sent out from the chip. Those are signals that are being what sent out from the chip. So here it all says bunch of signals that are all going out, and then here also you have a bunch of signals that are what that are going out, and then here it's a bilateral line. So basically this is not, so here EDP underscore aux, and then you have EDP underscore XS. So you have your N and P. Now this, it's a bidirectional line. So a bidirectional line basically it's so much so that a handshake, it's okay. This is a loose this is a loose explanation. So it's more like a handshake. The handshake has to be completed in order for that particular circuitry to be complete. So unlike your output signal, okay, again, it should be understood that for every output signal there has to be an input. Now, in the case of a bidirectional line, so you will have, it's almost as though you have signals that are simultaneously interacting from opposite sides. So you will have, for example, signal A and signal B. Now, signal A, the function of the signal A is going to be dependent on signal B in order for it to be present, just so as signal B will be dependent on signal A in order for it to be present. What that will mean is if signal A in this case is not, it's almost the same concept of your input signal and your output signal, but in this case it's a bidirectional line. And again, this is a bit of a loose one, but as we move on, I'm gonna try to make sense of that so that we can actually make sense of it. So here it basically would give you it tells you about the signals that are going out, and then here, so where you see that, just you see where it says out, that tells you about signals that are going out. Then here you say 60 and 67. So when you see 60 and 67, what it's telling you is that this signal here, this line here, this line dp underscore underscore int underscore ml underscore c underscore n, this particular line here, you will find this line, or this signal line, you will find it on page 60 and page 67. So say for example, for search purposes, you need this is on this page, on this schematic, you will find this same signal on page 60 and 67. The same thing applies on here. It says you will find this same signal, this same line, the entire line here, this signal that is quoted here, you will find that on page 60 and page 67. Now, so like I said, I'm not gonna let's try not to go over what is not here. So here again, you see that sign here, that tells you that the signal is what is going out. So you have the TP, which is typically your track point, your test point, EDP underscore display underscore UTIL. Now that is a signal that is what that is going out. And now say, so here you have your MCP underscore, for here you have your MCP underscore EDP underscore RCOMP. Now that signal, so see, that signal is directly tied to this chip here. Now what is this chip? This is a resistor. How is it a resistor? Because whenever you see the R, now that R there suggests that this component here is a what? Is a resistor. Now on this particular board, that resistor, this is the number of the, this is I was how do I refer to this? So this is the identifier of the resistor on this particular schematic. So if I am looking for this resistor on this schematic, I will have to type in R0530. Just an example. So if I want to look for this resistor, even though, let's say I'm just going to go back to my page one. So I'd say I go back to, so let's just get that again. So it's R0530. So 0530. So it's R0530. So I'm going to say, let's say I go back to, for example, I go back to my, let's go to page one, for example. Now at the page, so I want to search at the page, I want to search. Now, I didn't speak about the search that, but that is very, very important. So from the search, you are able to go to almost every page. Just that is just as important as the go-to option. So here, that we say it's so it's R0530, I suppose. Yeah. So you see where it says R0530. So we typed it there and then it pops up. Yeah. It highlighted that, okay, that is what we are looking for. Now, and then again, so just sometimes, if let's assume that we are looking to use, let's say that we are looking to use, we're looking for a resistor, this particular resistor, we're looking for it in a different board. We can also try to type it like this, but sometimes it might not, you can use it in similar boards. But say for example, this is a MacBook Air. If you look for this resistor on, let's say, a MacBook Pro M1, for example, this might not be, you might not have the numbering of the parts in this form. So but say this, as you know, this is a 2015 MacBook Air board. You can search for this. Say for example, you're looking for this part and then you don't have the exact donor board 2015 2017. You can use the 2013 2014 board, and then you can search for that, which is R0530. You can search for that part number on a 2013 2014 board MacBook Air, for example, and then you will find, and then you can get your what, you can get the resistor that you need. Okay, so and then here, so it tells you that it's a 24.9 ohm, the resistor, it's 24.9 ohm. And then it tells you it tells you about the tolerance, which is 1% tolerance, and then it's 1/20 watts. And here it's the pin 1 of the resistor, and this is the pin 2 of the resistor. So basically, in this case, for example, so here on that resistor will have a signal which is ppv comp_so_cpu. Now, usually when you see so, it's telling you that, so this is a signal line, and the SO in the middle here, the SO tells you the state of the board, the power state of the board when that signal is expected to be present. Now, why that is important, I'm just going to say that again. So this is PPV, ppvcomp_so_cpu. Now, this signal is also going to be, see next to it, it says 8. This signal is also going to be present on page 8. And what page are we here? We are on page 5. Okay. Let me see. Okay, so we are on page 5. Now, next to it, you have 8. 8 will tell you that this same signal here, you will find it on page 8. Okay, so ppvcomp underscore, under here, that's an underscore_so_cpu. Now, this is a signal. Now, this signal itself, it's going to be present. You will find this signal to be high or present when this signal is going to be present when the device is in SO state. So the power state when you're expected. So why this is important is, if I make measurements on this resistor and the device is in, for example, S5 state, so the device is off, for example, now I'm going to get 0 volt here. There is nothing that will be present here. Why? Because the device is not in SO state. However, now you again have to be able to know the description, the power state of that particular line, so that you will know when that signal that you're looking for is going to be present and when is not going to be present. Now, when you see SO, it's trying to tell you the power state of the logic board. Now, this particular resistor, that is the description for it. Basically, that is an ID, the way they identify the resistor, the name given to the resistor here. And because of the R stands for resistor, and then this point, this here, this side of it is the pin 1 of it, and this side of it is the pin 2 of it. So this it's basically a wire that is leading from the resistor down to your CPU, which is your U0500. Okay, so that's about the resistor. I hope we're able to make sense of that. So for this resistor, this is the pin 1 of it, and this is the pin 2 of it. So often, depending on depending on the ohm, depending on the rating of a particular resistor, that will determine its behavior. So typically, say for example, if this is a 0 ohm resistor, for example, so what will happen is if I have, for example, 1 volt on my pin 1, I'm going to have 1 volt on my, I'm also going to have 1 volt on my pin 2. However, the amount of, so the voltage will be the same, but the amount of power that will go through will be dependent on how much resistance how much resistance the resistor has. Okay, so that's that. So here it says EDP ports assignment. So we spoke about that, DDI and EDP. Now the next one here, it says DC underscore chain and NCT. So this is so this one, it says MCP DC chain strategy, and then it says each corner of CPU has 2 test points. Other corner test signals connected in DC chain fashion. Continuity should exist between both TPs on each corner. So TPs, I said, those are your test points. So here it says no test. Now, typically, when you're doing a repair, you are 9 out of 10, you're not actually going to be here. But I just try to make sense of what we have here. Here, when you see this NC, it simply means not connected. And your RSVD, that means you're reserved. So reserved are not generally used. You're not supposed to use your reserved. They are not used on the board. It's best to leave them as they are. But then if you are trying to do any whatever form of modification, then you can temper with your reserve, but be very sure that you know what you're doing in order for you to temper with the reserve. So when you see NC, it simply means that is not connected. NC is there is nothing happening on that part. So it's not used, it's not connected, so you have nothing to worry about. Say for example, and this is important, say for example, if you are soldering a particular chip, and the pad on your NC pad is missing, this is not something you should try to restore, because it has no relevance, because it is NC means not connected. Okay, so that's a little bit of this. I hope I'm able to make sense of this to myself, as well as whoever wants to make use of this. And then, like I said, 9 out of 10, you probably will not really find yourself here. But if you do find yourself here, what you want to be looking out for is you want to be looking out for what is going into the chip. And I want to say, for a schematic, basically, it's more like a map. Your circuit diagram is more like a map to explain to you what is happening and what you're expecting. So oftentimes when you find yourself at a particular page, it is because you're missing something. And then when you're missing something, you want to go find out what you're missing, where is it being created or generated from, what is required in order for that particular, for the signal or the power, the rail that is missing, what is required for that. Usually you're talking about enable signal, or which will come in form of a switch. What is being required in order for that data line, in order for that signal, in order for that power line to be generated. So when you come to a particular page, these are some of the questions that you will ask yourself. Okay, so this is our page 5. Now let's move now to our page 6. So we can say go to page 6. So we do that. We go to page 6. So page 6, we are still talking about our CPU. Miscellaneous, which is /jtext/cfg, which is your configurations, and then your your reserved. Now, so here again, so we're still talking about your CPU, the multiple parts of your CPU representation on this board. So let's talk about this here. Now on this page, this is our page 6. I think this is where we are going to end it off so that we don't have so much, and we don't want the video to be super long. Okay, so I had mentioned already that see the numbers just before the line. So here 58, 55, 51, 42, 38, 17. That is telling you that this signal here, this signal here, in this case it's a 1 point, okay, it's this is a power line here. So it's power plane 1V05 underscore SO. Now, the description of this, what this means is 1.5 volt. And this signal is only going to be present in this particular state, which is SO, when the device is on. So expect to have, now what it's telling you is that this power here, or the signal here, is present on page 58, 55, 51, 42, 38, 17, 16, 15, 11, 8, 64, 62, and 59. Now, we spoke about the bidirectional line here. So here it's basically, so this is a resistor, and this resistor here, in order for this resistor to function, it needs to have power, and that power is going to be present only when the device itself is on. We spoke about what this is. This is your this is what a resistor looks like. That is how you that is the representation of your resistor. Here we spoke about in terms of the ohms. So it's 62 ohms, and then here you have R0610 0. And then again, here the side of the resistor is your pin 1, and the side of the resistor is your what? Is your pin 2. And then we spoke about how this is a 1 to 20 watts of power. So it will be, this is this is the rating of the resistor. Your power rating of resistor is 1 to 20 watts, and then the tolerance is, that's your 5% tolerance. Now in this particular case, you have a signal that is coming through. In order for this particular resistor to function, you have a signal that is going to come through on your pin 1. It goes, and then so on the side of the pin 2, this is a connector, a connection point. So a connection point, basically, here you will have R0611. It's tied together with 0610. R0610 is tied together at the pin 2. So what this will mean, so if you see here, pin 2 of R0610, and the pin 2 of that resistor and the pin 2 of R0611 are connected, which would mean that if you are soldering, or if you're working on your circuit board, if you have a bridge between your this two, the pin 2 of R0610 and the pin 2 of R0611, you have nothing to worry about because they are tied together. Here, this dot here tells you that they are tied together. So the pin 2 of the resistors are tied together. The pin 2 of it and the pin 2 of it are what? They are tied together. So now attached to that is what you have, your CPU underscore PROCH OT underscore L. So the L here is, so we are going to talk more about the L. So the L can the L will have different function depending on how it's being quoted. So typically, you will say that that particular signal will be active when the signal is low. So we will talk more on the CPU underscore. We will talk more on the L signal. But so here you have a communication that is tied on the, so you have your pin 2, the pin 2 of this two resistors are what? They are tied together. So just like this one, so this one, this is 56 ohms. The resistor is 56 ohm. This is the pin 2 of it, and then the pin 1 of it, and then it's 5%. It's basically very similar to this. So you said it's 5%, it's 5%, but this is a 56 and this is a 62. And then the tolerance, that's you have your 5% tolerance. So you have that signal making its way, and you see where it says it's bidirectional here, and then when you trace that signal here, you see how it's also been represented. You see that's a bidirectional. That's a sign for you to tell you that it's a bidirectional line. This is a bidirectional line. That is the line that is going out, and this is the line that is going in. Okay, so NC would typically means it's not connected. So here CP, so here now CPU underscore CAT underscore L, that it's going out. Now PECI, that is a bidirectional line. Now this is also a bidirectional line, and then you have typically I will say you are having various section in the chip in the chip function. So you have that, which is for your thermal. You have your PRC power good section there, and then you also have the DDR3 section. Basically, that is for the RAM power, and then your thermal, and then you have your miscellaneous. And then you have your JTAG function here. So typically here, you are looking at this sign will tell you that that is going out. You see, it clearly says out, and that's the sign that you say that is going out. Typically here, when you are looking for signals that are going out, be sure that the in signals, which is typically will be on the other side, are present. But in this case here, you have bidirectional. Now, mind you, this it's a sec this so it says 2 of 19. So this is 2 of 19, remember. So let's do this. So this is 1 of 19 on page that you remember we have 1 of 19, and then here we are dealing with, no, this is 19 of 19, that's the end of it. Yeah, so 2 of 19. So this is the same chip but different section of the same of the same chip. So we have a PRDY. So that is your XPD, and then this is the signal that is going out, and then this is the signal that is coming in. And just next to it again, like I said, you have 16, 64, 67. This signal you will find on, this signal will be present on page 16, 64, and 67. Now, if I want to search the signal, so what I will do, if I want to see where else the signal is present, let's say for example, that I want to see where the signal is present on my board, two things I can do is I can just copy this. Let me see, I can copy that and then paste it on my search. I can paste it on the search. And then that will typically take me to page 16, 64, and 67. So let me just show you guys that. If I click on enter, so it says found on 4 pages. And here, so it's we have a match. So fine, so we have it here. It says highlighted here. It's highlighted here, and what page is this? This is page 16. Okay, so let's see, and then if we say next again, where do we find it? We have it here, highlighted here. And what page is this? This is page 64. Okay, so let's next again, and then what page is this? It's highlighted here. So you see it also, it's highlighted here. And what page is this? 67. Okay, and then let's go to the last one, and this is where we started off from. So you see 16, 64, 67. I'm just going to go again. So this is the first page. This is page 1. It says it's found on 4 pages. So this is going to be the first page, second page, third page, and the fourth page. So if I go next, it would tell me that we are what? Page 16. So if I go next again, and that is page 64, and if I go next, it's found on what page? Page 67. And if I go next, it will take me back to where I started from, which is here. So then the same thing is I can also copy this and paste it on my board view to allow me to see where that signal is what it's present. Okay, so so that is that. So this signal is what is going out, and this signal is what is going in. This is a signal that is going in, that's a signal that's going in, a signal that is going in. These are signals, and then these are bidirectional lines. These are bidirectional lines. And then on the side, so here, so So this is a resistor, a resistor, a resistor, a resistor, a resistor whose pin 2s of this resistors 1, 2, 3, 4. There's 4 resistors here. Their pin 2s are tied to ground. So 1, 2, 3, 4. They are all what? They are all tied to ground. So you have their pin 1s having signals, and then their pin 2 being tied to ground. So that's that on that, and then we are going to finish off here. And here it's page 19. Like I said, we are dealing with the different sections of the same chip. So we have configuration 0, configuration 1, and whole lots of configuration, because because it's a CPU, it's the brain of the machine. So there's so much to expect on the CPU. So you have the PRO C underscore PI underscore compute underscore compute. You have a resistor that obviously will the that has its pin 1 tied to a signal and the pin 2 being tied to ground. Now, obviously, you see that there is a form of there will be communication that will take place here, and then this is a 49 ohm resistor, so which means that the signal on pin 1 is not directly making its way to ground, but then it's a form of communication. So it's a form of communication, and then obviously that communication will happen when somehow some part of that signal makes its way to ground. So obviously so this sign here, that's a sign for ground. So ground typically means 0 volt. So you only expect to see 0 volt on your what? On your ground. And then we spoke about NC will mean that is not connected, and then you also see close next to that is also your reserved, which is it's not used, so you don't have to worry about that. Now your VSS is also a form of ground, so you don't have to also worry about that. That's your ground. You have again reserve, and that's your NC. So you shouldn't worry about that. Same thing applies here. All of the signals are not utilized. They are all not connected. Then you also have for data handling. You also have these resistors are used for data or signal for signaling. That's your R0680 and as well as your R0685. And then like again, you see that they are high ohm resistor, so they are not 0 ohm resistor, which would mean that the signal is not directly making its way to ground. And again here, these two resistors are tied together at their pin 2, and that is also which is then tied to ground. Okay, so that's that. And then here, let's see what it says here. So it talks about configuration 10 safe mode boot, and then normal operations. Okay, so yeah, this can be placed close to J100. Okay, and then and are only for debug access. So basically for um when you're trying to do some form of debugging. So yeah, that's when you need that. And then no stuff is basically what it says. No stuff, nothing. You shouldn't expect anything there. So yes, you see that it's there, but when you check the board, there's nothing there. So no stuff. When you check your main board, there's gonna be nothing on the board just because it says no stuff. So there's not gonna be anything there. Okay, so EDP is your embedded display port, and then that also you have a resistor, and that's a 1K resistor. This is like so 1K, that's your 1000 ohm resistor. That's 1K. So that's quite a high one. So that's that, and here, and then yeah, this is about your CPU. MIC slash your JTAG, and then just something about your JTAG. So oftentimes when your device is liquid damaged and then you have liquid in your JTAG, it would cause your device to act, in a very abrupt manner, or in an unpredicted manner. For example, your device might either be slow, device might not power on, the device might just act in a very strange manner, So usually if you have a device that you're working on, especially on the MacBook Air like this one, and you have liquid on your JTAG, or if the JTAG is looking funny, I think it's best that you remove the JTAG. Removing the JTAG, as you know, your JTAG is basically um, an easy connector access in order for you to interface with that machine. So and that is an interface that you probably use like once in a lifetime. Not being on not you not having it on the board, you are actually okay. So it doesn't play a primary role to the device's function. So it's basically an interface that allow you to interface with the main board. But if you have liquid on that section of the board, it's going to affect the function of your device. It can cause various problems to the device. So the best thing is when you're doing a repair and then you see that you have liquid on your JTAG connector, please remove it. Okay, so that's about that. And so that's where we are going to stop today. And then we are going to continue from here. And if we have questions, yeah, so we can always ask, and then we can, like I said, this is so what we're going to be doing is we'll be going page by page, try to make sense of it to myself, and hopefully somebody will be able to derive some form of benefit from it. Okay, thank you guys. Inshallah, I will see you guys in the next one. Bye for now.